Today we are going to learn about the cleansing materials or methods. That means some soaps and detergents. That means we use different types of soaps and detergent, but many of you or some of you may know or some of you may not know how it works or how it can be prepared. Sometimes you can prepare these types of soaps at your home. Okay. So if you have some ingredients, then you can prepare the soap in home. Because I have seen in Korea and even in USA, some kids their synthesis or they prepare some soap and they try to sell it. But they do not have the brand. Normally, the different company have some special quality. But when the students prepare by themselves, just they are practicing so that they can prepare or they can make the soap. So that is very simple process. But in Bangladesh, we do not have very good opportunity to purchase some chemicals. But in laboratory, you can have some chemicals. So you can make some soap in the laboratory also. So in your lab class, you can try for that. If you have some opportunity, then you can go to it. So today we'll learn about the soaps and detergents. That means some cleansing material. Sometimes we may have lot of dust in our dress and any other things. So how we can clean it? That means how the soap or detergent works to clean it. So soaps and detergents are used for washing. All of you are familiar because every time when you go home or when you come to campus nowadays, previously we didn't have to use the soaps in our campus also, but nowadays very often we need to use it. So how it works, we will learn it. What are the types of soaps and what are the components? It dissolves dirt. That means all the soaps and detergent have some component, that means chemical. How first of all we will learn what is soap or detergent. Then we will learn how it can work or how it can clean our dirt or dust, whatever it is. Just mainly you need to think the dirt or dust, that is kind of hydrocarbon or some kind of oil. So if I have some dust in this jacket, in that case, that means dirt. Let us consider dirt. So that is kind of oil. So you need to have something that it can attract the oil. That means if this jacket is dirty, that means it has some oily substance. In that case, you need to use some chemicals so that it can collect the oils so that it can clean up. Therefore, we have to think about how we can all the oils are alkanes or hydrocarbons. So you need to think about, in one of the last classes we have mentioned that what types of substance can be dissolved into if water is dissolved, if you take sodium chloride, then if it is soluble in water, is it? Then if you take kerosene, if it is soluble in water, then why not? Because hydrophobic, that's good, but mainly the hydrophobicity comes from if it can form hydrogen bond or not. Is it? When you have the compound water, in that case, if the molecule can form hydrogen bond with water, then it dissolves. If it cannot form the hydrogen bond, then do not dissolve. That means you have the term like dissolve, like solvent. Is it? Or like this way, if you have some polar solvent, the polar molecule can dissolve into polar solvent. You are familiar with this? So if you have, that means if you have dirty in your jacket or in your clothes, That means the darts are hydrocarbon. That is some oil. So oils are hydrocarbon. So that means this is non-polar. So you need to have something which can dissolve into hydrocarbon. So it has some dart, that means it has some oil. So you need to have something. Normally we use water to wash our clothes, but water is a polar solvent, so that cannot be washed into water. Then how it can happen? In that case, you need to add some compound, that means which can dissolve the dirt. That means the dirt can make hydrogen bond to the oil, sorry, the compound what we are adding like a soap or detergent. So now we will see it dissolves dirt, but some dirt will not dissolve in water. So some of the dirt, already I have mentioned that if you have some mud, that means maybe sometimes if I use the dirt drill, so you may have some, that is possible. Yeah? You can have some dirt like dust that can be dissolved into water. That is easy. But if it has some, if I use this, then that comes some oil, is it? That cannot be washed with water. So that means if you have water, then you can dissolve something which is polar. But if you have something which is non-polar, then you need to have something that is also non-polar. So non-polar will dissolve, and polar dissolve. So we have some type, that means we use some chemicals made of detergents are of two different types. So let me show you what is the a soap is the sodium salt. That means a very long hydrocarbon chain salt of what? Hydrocarbons. A soap is the sodium salt or potassium salt of long chain carboxylic acid, fatty acid, which has a cleansing properties in water. Actually, what is this? We have a very long hydrocarbon, and later we will show one by one example. It is a salt of a strong base. Why it is something? It is a salt of a strong base, sodium hydroxide, and weak acid, carboxylic acid. So a solution of soap in water is basic in nature. That is, I'll discuss. But first, I want to show you what is the. Okay, see. This is our soap. Okay, so this is a CH214 CH3. That means this is a compound glyceryl triphthalimate. Palmate. Sorry. So palmitate, glyceryl palmitate. Sorry. So this is our compound. This is a acid. Sorry, ester. This is ester. So this two CO. This ester and reacts with some sodium hydroxide, just base or alkali. So it is forming, we do not need any this one, but this is a salt made of this. When you have some acid and alkali, they will form some salt. This is also a kind of CH2 COO, and this is an ester. When it reacts with alkali, that is also forms this. So this is a salt. So if we write down the structure for this molecule, in that case, sorry, any question? Okay, this has a very long chain. If you write down CH2, 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 like this way, and then CH2, CH3, and other side, it will have COO, many, like this, is it? Something like this. So this is a compound of, that means sodium salt. This is a compound of sodium. So that is sodium salt. So this part is hydrocarbon. Is it? Hydrocarbon, very long chain hydrocarbon, and we know that hydrocarbons are non-polar. Is it? So we can consider this is a very long tail, and if you consider this part, this is head. So we can compare, this is head and this is very long tail, and this part is non-polar, so it will have some attraction towards the non-polar part. That means the oil also kind of hydrocarbon, which is non-polar. Therefore, you have some soap or detergent little bit different, but that is also a kind of salt. But we are using here hydrocarbon or alkane, but in case of detergent, that will be some benzene or something, aromatic ring. Later we will discuss this. So first we are considering this is hydrocarbon. So this is very long chain, and this is our head, this is tail. So this is non-polar part. It will have the attraction towards the non-polar part or dart, with the dart, and this is polar, and that will attract the water, and that will attract the dart. Okay, so a soap is the sodium salt, what we have mentioned here. First we would like to show detergents are of two types. That means, okay, detergents are of two types: soapy, also known as soaps, non-soapy, also known as synthetic detergents. That means some of them have very too much bubbles, and some of them have very little bubbles. So soapy and non-soapy, you can consider. Here, the global soap and detergent market was valued US 119.12 billion in 2019. That means in every year, how much North America, Europe, Asia Pacific, Southern America, and the soap and detergent market by product 2014 to 2025, we are expecting. So day by day, but as I guess, this data was not in this region that was predicted, but I guess right now use maybe up to this, because nowadays we are using more and more soaps compared to any previous time. So I guess the production and use of soap has been increased quite a lot, which has not been predicted earlier. So global market or global importance of the soap and detergents are increasing day by day. Every year, as we go from here, you can see 2014 to 2025. So I guess from now on it will continue the same situation, because as we have seen that the COVID situation is not going to recover very soon. However, we are going to have the vaccination. Everyone is getting vaccine. However, most of them have the possibility to have the, and all the vaccines are not 100% pure or 100% cannot recover us, or 100% prevent. We can 100% it cannot prevent us. Therefore, we always need to be careful. So we always need to use more and more soaps and detergents. So what I have said, that is a salt of a strong base. So soap is the sodium salt or potassium salt. That means we have shown that sodium hydroxide reacting with some compound to form the salt of the that means that is the soap. Not only sodium, or not only sodium hydroxide, but other potassium hydroxide that can also be used to prepare the soap. That means either sodium salt or potassium salt of a long chain carboxylic acid, fatty acid, which has cleansing properties in the water. That means which can remove the dirt from any clothes or any other substances. So it has some cleaning property. It can clean up. It is a salt of a strong base and weak acid, carboxylic acid. Normally, you are familiar with the reaction like this: HCl plus NaOH. So you are getting NaCl plus H2O. Okay, fine. So this is very strong acid, a strong base, salt, and water. Okay. Now, if you have CH3COO, then we are replacing this acid by this. This is ethanoic acid, weak acid. Okay. It reacts with same, that means sodium hydroxide. Then you will get CH3COO Na plus H2O. Same thing. So this is our salt of weak acid. Is it? Salt of weak acid and a strong base. It is a salt of a strong base that is common and a weak acid. This is a weak acid. So that is also can be considered as some soap, but not actually, because this chain, that means CH3, this is not long enough. That means when we consider for soap, we need to have certain chain. That means it can act like as non-polar. This methyl, if we consider for this ethanoate, sodium ethanoate, in that case, this part, not this part, this CH3. This CH3 part is not long enough to work as a cleaning agent. Therefore, so, but as a example, if I say now, if we replace this molecule, same thing here, CH3, CH2, let us say that means we have increased the chain length. In that case, you will get the salt like something CH3, CH2, 17, COOH. So we will have CH2, that will be CH2 inside, and that will be 17 and CH3. Now you can consider that is as a salt. So how we have prepared? Just the carboxylic acid and sodium hydroxide, weak acid, a strong base, forming the salt. That means salt of sodium or sodium hydroxide reacting with carboxylic acid to give the salt, and that is the soap. Previously, I have shown you that slide. Saponification. Do you have the idea what is the meaning of saponification? Anyone who are in the online, do you know the meaning of saponification? Oh, already I have in the display. So, just how we can prepare the soap. Just the process of making soap, that is called as saponification. Okay. The process of making soap from animal fat and vegetable oil using a base. So common is these types of base or alkali, a strong base, and then we have to use animal fat or vegetable oil. So both are also different types of fat, that means a kind of fatty acid, or vegetable oil, that is also kind of fatty acid. So as already I have shown that this is our first reason. So here you can have, this is very long compound. So here this component is giving a glycerol, that is side product. Some of you can use this glycerol. This is quite cheap. So this is quite cheap. You can have this product, and so when this one molecule, this is just single molecule, but the structure is, here you have CH214, CH3, CH214, CH3, CH214, CH3. So just CH, CH2, CH2. Very simple example. You can remember, is it? All of them are, you can consider easily CH2, but as this carbon in the middle carbon is bonded to 3 different components, therefore it should have only 1 hydrogen. So this is, it has 2 hydrogens, this has 2 hydrogens, and these are asterisk group. So this is same, these all are same. So just CH214 CH3. So as I have written in the previous way, CH217. So you can write down. So that is the specific compound. When it reacts with the sodium hydroxide, then it can form the glycerol in addition to the soap. Sodium palmitate, or that is soap. Sodium palmitate, that is the structure. So this is the hydrocarbon part. This is very long. Actually what we have written here, CH214 CH3. That means ultimately in this side we have 15 carbon atoms and 3 for 28, that means 31 hydrogens. So you can have here, if you count from here to here, you will have 15 carbon atoms and 31 hydrogen. Just easily, you can, all the carbons have 2 hydrogens. This carbon has 3 hydrogens. Just same thing, whatever we have represented. And the chemical formula CH3 CH4 CH214 COOH. That is the formula for what? Palmitic acid. That means what we have, this is the ester, but actually we can use this one also, this palmitic acid, because as I have shown, ethanoic acid plus sodium hydroxide, it reacts to form sodium ethanoate, that is also a salt of weak acid and a strong base. So when this palmitic acid reacts with sodium hydroxide, or even it is possible to react with only sodium to get the salt of this carboxylic acid, because you are familiar with the reaction when any acid reacts with only metal. In that case, you can get sodium chloride plus hydrogen gas. In that case, the balance will be, okay, that is also possible. So if you have this acid, you can add, but industrially it is not good to use the pure sodium. Instead, we can use sodium hydroxide, so that we can have either this palmitic acid or the ester, glycerol tripalmitate. Right? So we can use these 2 products, palmitic acid or hexadecanoic acid. That is a little bit confusing name, but I think this is even better. Hexadecanoic. You are familiar with the word decan, non-decan. That means having 10 carbon atoms. The hydrocarbon having 10 carbon. So hexadecan, 16. Hexadecan decanoic acid. So Just you can consider how many carbon atoms you have in this compound. This is 14, 15 and 16. Hexadecomic. Is it very simple? So hexadecomic acid or palmitic acid. This is the common name, palmitic acid. All of you have some pet name. Some of you, maybe not all of you. Some of you. So we can call this is palmitic acid, or you can call this hexadecanoic acid. So when this hexadecanoic acid or palmitic acid reacts with sodium hydroxide or potassium hydroxide, it forms a salt which can be used as soap. Most common fatty acid saturated found in animals, plants and microorganisms. Most of the time, what what ingredients are used to prepare the soaps that are fatty acid, and that fatty acids are mostly saturated. That means you may have you may like to eat different types of fatty meat, so you can have most of the animal. We collect the fatty acid or fat from different types of animals or sometimes some vegetables. So most common fatty acids saturated. This is saturated fatty acid. That means just like this one, we can consider saturated. That means having no double bonds. Okay? Carbon carbon, no carbon carbon double or triple bonds, no multiple bonds. So that is saturated, found in animals, plants and microorganisms. We can have in animals or plants, but sometimes we can have in microorganisms also. Some other examples of soaps: oleic acid, mono unsaturated omega-3 fatty acid. Okay, all of you are familiar with the word omega-3 fatty acid, is it? Yeah. And it has little bit higher cost compared to any other, maybe soybean oil or some mustard oil. If you have any oil containing omega-3 fatty acid, then you are normally in super shop. If you go to the super shop, then you will see that mustard oil may have 240 per kilogram or per liter. But if you have some oil containing omega-3 fatty acid, or even some egg, if you have the egg omega-3 with omega-3 fatty acid, in that case the egg is maybe almost double the cost. So that is quite expensive. Why? Sorry, omega-9. Sorry, omega-9. Whatever, but omega-3 and omega-9, mainly we are interested on unsaturation. We are interested in unsaturation. If any compound, that means if any oil has unsaturation, in that case, that oil can be broken easily. So if you have some oil, that means mustard oil or soybean oil, whatever, normally, if you use that types of oil to cook, that will store in your body for a long time. And if you have lot of oil, that means if you eat lot of different types of fried foods, in that case, you are consuming lot of saturated oils. In that case, that will remain in your body and you will get fatty. That means your blood will be very fatty or your body will have lot of fats. But if you have this unsaturated compound, that means this is easy to decompose. So if you have this oil, that means if your oil contains some double bond, in that case, that oil can be decomposed relatively easier. So if you do not have the double bond, then that will remain for a long time. If you have double bond, then that will decompose relatively easier. Therefore, your body will be safer compared to with the saturated oil. Therefore, people are interested to have the unsaturated, sorry, unsaturated one. More interested on unsaturated one, but the availability of these types of unsaturated oils are not very high. Therefore, you have to spend more money. So, oleic acid, mono unsaturated omega-9 fatty acid. So, this is another example. So, if you have some double bond, then double or triple bond, normally double bond, because triple bond containing compounds is little bit rare in that case. So, if you have occurs naturally in various animal and vegetable fats and oils, so these types of oils are found. Even you can have some sea fish. In some sea fish, you can have these types of fatty acid. Okay, so that types of sea fish are quite expensive, and many people even do not like the smell of sea fish. So, but as far I know, all the sea fish has more minerals compared to normal or just no salty water or normal water. So if you can have the opportunity to have the fish from sea, then it's better to have not to avoid for the smell. Okay, this is another sodium oleate. Sorry, this is another soap. So we have some example. Sodium stearate, which we use most of the time. This is the most useful soap, sodium stearate. From the when I have started to learn about soap, maybe class 10, 9, 10. Since then, I am familiar with this compound. So all of you should have some knowledge about this sodium stearate. Thus, when I have started to learn about soap, first example I learned sodium stearate. Already I have given the structure and everything, the slide in there. Okay, another thing. I have given you the syllabus and I have some plan that what I have mentioned that we are planning to have our midterm on the March 8. March 8. That means we have vacation. That means not vacation, just 1 week semester break. We have 1 week semester break on the March 13 to 17. 11 to 15. I have seen in the academic calendar that is yesterday. Yeah. That is. We do not count that one. We can count from Sunday to Thursday. So that 13 to 17. 13 to 17. So that is our. So you can count from 11. That is okay. Okay. So what I'm going to mention that. Okay. So this is the soap. This carboxylic group already I have shown you that is we can consider that is as head, and this is the tail. There are so many things, so many examples. So what we need to prepare a soap, how we can synthesize soap? Tallow obtained from cattle, sheep, goat, etc. Olein 40% and stearin 60%. That means what types of compounds or chemicals we may need to synthesize soap. Soap prepared from tallow alone is hard and water insoluble. That means water insoluble. That means most of the case. That is, have you ever seen some very big soap in the roadside? You can see some like a ball that is.
Tallow, is it like extracted from the leaf?
This cattle, sheep, goat, you have different types of different types of animals. Sorry? Yeah, fact. Yeah. So already I have mentioned from where we can get it. In order to make it soft and water soluble, it is mixed with coconut oil. But in that case, that soap becomes little bit expensive. Normally nowadays the coconut oil is quite expensive. So if you have some soap which is very hard, and normally it do not dissolve with water because the very long part which is hydrocarbon mostly, and very small part or composition for head part, that means carboxylic acid part, that is not very effective. So if we want to make it more soluble with water, in that case we can add some coconut oil, palm oil or cottonseed oil. In that case it can have the capacity to dissolve into water little bit, because in that case the chain of the hydrocarbon becomes little bit shorter. If you have the hydrocarbon as shorter, that means you are familiar with the tendency, the solubility of hydrocarbon decreases with increasing the number of carbons. So the tallow, what we call it, so this compound has very long hydrocarbon. In that case, if you add some coconut oil or palm oil, this compound has little bit shorter tail, so that it can be easier to dissolve into water. Grease or lard obtained from male pig and smaller domestic animals. You can see this. It is soft like butter, used for making best quality soap. That is from pig. Don't get confused. So some of them have some okay. Some of them are not interested. So palm oil, toilet soap, pumpkin, olive, castor oil, transparent soap. Here one N is missing. Transparent soap. We can have some soaps which can be, sometimes you can have different types of color, but some of them can be even transparent, not by 100% transparent, just colorless sometimes. Yes. Male. Okay, sorry. It should be male. No. MALE. Not male. MAIL. This should not be MALE. Because there is nothing male, MAIL or female. Okay, linseed oil. If you want to prepare some soap, that means the soap which are little bit softer compared. Some of them are very hard, and some of them can be quite soft. So if you want to make soft soap, in that case you can use linseed oil, linoleic acid, these types, and unsaturated, di-unsaturated. That means you have two double bonds. Why it is jumping? Di-unsaturated, that means if you have some carboxylic acid with two double bonds, then that can be even better. So for any oil, if you have as many as unsaturation you have, the quality of oil is considered much better. So if you have some the acid, that means the soap, if you have the soap having the unsaturation, then it becomes even softer. cottonseed oil, olein, stearin, and palmitin, soap, leathers freely. Ground nut oil, large proportion of unsaturated oleic acid, so form very soft soap. Maize oil, fatty acids, and different things. I am not interested. Common salt. So common salt we can use, that means sodium chloride. Just common salt, or different types of salt we can use to prepare the soap also, and also other additives. In last class, while we have been studying the polymer, we have mentioned several types of additives. So in case of soap, we can have several types of additives. Sometimes you can have the rosins, plant product obtained from pine tree, abatic acid, modified by hydrogenation, polymerization, increases leathering property. So based on what property we are interested, we can add different types of ingredients. Maybe we can change the flavor, we can change the color, we can change the hardness. That can be. Sometimes you can use, if you have right now we are very close to the sea, is it? So you may have the salty water, then you need to have some soap which can be used in salty water, but all the soaps cannot be used in salty water. So depending on what types of water you have, that means if you want to clean up the dust or dirt, then you need to use different types of soaps which work on salty water or normal water. So based on the region or area where do you live in that case you need to choose your soap also. Builders, that means not the building maker. So the builders, that is also kind of building makers, I would say. We are making the soap, so we can have some chemicals which can combine all the ingredients. So we can consider, increases cleaning capacity, texture of soap, prevention of precipitation in hard water, sodium metasilicate, not metal, borax sodium borate, washing soda esters. We can add these types of builders so that it can increase different types of cleaning property. So if you add washing soda, borax or sodium borate, these types of ingredients into the soap, in that case it can increase the cleaning property, or some texture, it can change the color or it can change the flavor also. Antioxidants, some of you may use neem soap. So that may be considered to prevent the skin disease. Or some antioxidants, sodium thiosulfate, EDTA, sodium hyposulfite. So different types of chemicals can be added to the soap so that it can be useful like as antioxidants. Fillers, magnesium carbonate, chalk, coloring matter, perfumes, fixatives, optical brighteners. So these types of chemicals or ingredients or additives we can add into our soap. Types of soaps, we have different types of soaps: washing, toilet, shaving, industrial, and even deodorant, freshness, baby soap, herbal or medicinal soaps. There are several types of soaps, but one very important thing, we have all the stars from cinema or athletes. They have we bring them to advertise, but none of them actually mention from which ingredient or about how the soaps are prepared. So, among the consumer products aggressively advertised, bath soap are in the top of the list. Although a bath soap basic function is to clean the body, the advertisements confer exotic qualities to it. Soaps are being advertised as beauty soaps, health soaps. All the soaps have the same purpose, is it? So, but one thing, if you have one thing, you need to be careful that if your soap has lot of alkali or very strong alkali, in that case your skin can be damaged. So just be careful not to not very highly basic or not very highly acidic, just neutral. If you have your soap neutral, close to neutral, little bit basic it should be always, because as we have mentioned that we are adding alkali to the base, so a strong base, so a strong base and some weak acid. So the salt which is producing from this reaction, it will have some characteristics of alkaline characteristics. Yes.
The fatty acids are all extracted from the from the
Animals
and vegetables. Is there any cause if we don't use those? Will it impact?
Sorry.
If we don't use that the fat that is extracted from the animals or the vegetables, does it have any does it make change in the food?
Then how do you want to synthesize the fatty acid by yourself in the laboratory?
Do we have any alternatives?
Right now you can synthesize some fatty acid, but that would be even too expensive compared to collecting from different sources like as animals or fats or vegetables. So to synthesize some fat, what is needed for preparing soap or synthesizing soap, that is possible because now it is many different types of compounds we can synthesize. But to synthesize that fatty acid, you may spend quite a lot of money and the production is very less. Therefore, why people go for production in the laboratory or some industry? Because if it has some profit. So if you want to synthesize something which cannot be sold out, if you spend a lot of money and if you cannot get that money out, then you are not going to make the business. So
From the living animals.
Sorry?
Like those kinds of extracted from the living animals or
living animals, I don't think, because we are using different types of using different types of animals to have, or always we are slaughtering. So we use different types of animals to take to eat, is it? So the part who is normally people do not eat, that means the very highly fatty part. So most of the people do not eat, and many cattle farm. The cattle farm, just they collect it differently. The mostly fatty part they do not sell to the people. Just they collect the fat from that part so that they can even. But normally, when one people purchase maybe 2 kg or 1 kg of chicken, that time you are not going to get the oil out of it. But when you have a very big cattle farm, you are producing tons of tons meat, and then you can sell or you can collect the fat, so you can transport to the industry or you can sell it to the industry. So normally just to collect fat, we do not kill the animal, but we collect and fat in another process for another purpose, and then we collect it. What is this? None of the advertisement is speak of what exactly goes into the making of such soaps. Can medicated soaps readily cure skin disease? So what is the purpose of the soap? Just to clean your body, is it? So some of the ingredients, if you think it can mainly it can use to clean your body and your face, whatever, but not very effective to cure the skin. You believe, but in reality, maybe not so. As mentioned earlier, soaps are salts, particularly sodium or potassium, of long-chain fatty acids. These carboxylic acids are derived from fatty oils. The principal active cleaning agent is sodium carboxylate. So, what we need to clean up, that is sodium carboxylate. And then chemical reaction. Just how we can synthesis. This is the soap making. We want to see how does soap clean. That means how soap works. This is our soap. Water yeah, this is the water loving. I cannot see from here, but I can see in my display. So this is the water loving. Already I have mentioned that the water loving and water hating. That means water is a non-polar compound. Polar compound. Sorry, water is a polar compound. Therefore, water polar compound. Therefore, this non-polar part do not attract with the water. Therefore, they repel each other. Almost, I would say. So if it do not attract, then it is repelling. So that is water hating or hydrophobic and hydrophilic. That means hydrophilic and hydrophobic, that two terms comes just with one love and one hate. Okay. So now soap dissolved in water. A soap molecule has a long hydrocarbon end and the short ionic end containing COONA or potassium ion. K plus or the non-ionic hydrocarbon ends. This is our non-ionic hydrocarbon end. The property to repel water, hydrophobic tail, phobia, hydrophobia. Have you ever heard that? This is kind of disease. So if some dog bites someone, then we can have the symptom like this, hydrophobia, hydrophobic. That means if the dog bites someone, in that case, we can have the disease hydrophobia. That means if you see some water, then you can be afraid of water. That is the who do not love water. So that is hydrophobia. So the ionic end has the property to attract water. Therefore, this part, this is the COONA. This Na plus is positively, and this is COO minus. So this is kind of ionic part. Therefore, we can consider that this part can attract water. Okay. Hydrophilic, the hydrocarbon end attracts to the dirt or grease to form a structure called micelles. Now, if you have, this is the dirt, the big. So let us consider this is the dirt, and you have lot of water outside. Then this is the soap. So this soap, this part, what happens? This is the head. This head part. So this head loves the water. Is it? And this part is the tail, this long tail part, and this is hydrophobic. It do not love water. It loves oil, hydrocarbon. This is hydrocarbon. So this dirt also hydrocarbon or oil. So it can have the bond, it can attract. That means this part can attract the oil or dirt. Therefore, when the soap attracts that means this long part, when attracts the dirt, then it looks like as this is one soap molecule, this is another soap molecule, this is another, this is another. So in that case, now you can think that this part attracts with water. This part, this are attracting with water. Therefore, now we have lot of water, and this is making bond with water. So now when you have just if you add soap into the cloth or anything, in that case, this oil molecule or dirt that can be taken away, because this long part is taking the bond or it is attracting the water, oil, and this one, and then just wash away. It will float. This because this part is attracting to the oil and this part is attracting to the water. So you can remove the water and wash several times or 2 or 3 times. In that case, you can take away the dirt. So by this way, the someone. Okay, so we do not have more time. So yes, do you have any question? Okay, maybe what we have more next. Same thing. Cleaning action. Same thing. Okay, so today we are not going to get anything more. So now we'll take the attendance.